guys, welcome to MagicCAD. Today I'll be showing you how to use the GF Basic Gear Generator for Fusion 360. This is an add-in we made initially for 3D printing planetary and simple gear trains, but as time went by, we expanded its function to allow more complex types of gears. It's made after the DIN metric module standard, however it does derail a little bit from it, like with the inclusion of 30-degree pressure angles for example. So it may be more useful for 3D printing enthusiasts. We hope we can add in the future the capability of designing gears using the pitch system, so we don't leave anyone behind. So in this video we'll be covering the basic features of the app and its characteristics. If you don't know much about gear design, we're planning to make a future video covering that. Without further ado, let's get started.
We begin by downloading the files and decompressing them. Then we go to the Add-ins menu and select Add New. We paste the route of the folder and then we run it. Once loaded, the application will be added to the Tools panel. It will show a drop-down menu with a gear icon. When clicked, it will show all the gear variants we can choose. For example, let's design a classic, the Spur gear. As you can see, it displays a pop-up window in which we can input the characteristics of the gear, pressure angle, gear height, etc. One interesting thing is that all the variants except the Rex have the Fast Compute option. The Fast Compute option is pretty self-descripting. However, it's important you understand how it works so you can decide when not to use it. Since Fusion doesn't support the equation-driven curves, the envelope of the gears is made with a spline. If selected, this option sets the amount of points for the envelope spline curve to 50 regardless of the module, making the complexity of the sketch easy to handle. If it's not selected, the amount of points could go up to 450 depending on the module, giving more precision to the curve. Basically, you should always select this option unless you're laser cutting, 3D printing, or require that extra amount of precision. All gears will show up at or near the origin, and they're built in a way that the process does not interfere with any existing bodies at that position, so you don't have to worry about them merging or something like that. They also have a sketch with the most important parameters the gear was made with, so you don't have to write it down in order to remember and avoid starting over. Each gear has its timeline grouped, so if you're working with many gears at a time, you can check their characteristics by deploying sketches, selecting the last sketch of the group, and making it visible. Another important thing to mention is that not all gears are made to standard. Some are experimental, like the profile shifted and the non-standard internal ones. They were included because they've proven to be quite useful in 3D printing and respect the dimensions they're supposed to have, but they don't reflect the standard geometry nor the results of the manufacturing methods. If you plan in using these designs in an industrial level, you should not trust them to hold up to your end product or even look like they do on Fusion. Another important feature of the add-in is the worm gears. There's two types, the helical one, which uses a helical gear for the drive, and the hub straight one, which uses the screw profile to cut the gear. Another thing important to mention over here is that when you input the radius of the screw, it will be this one and not the overall radius of the screw. So that's it for the video today, guys. Hope you enjoyed it. Leave a like and subscribe. If you have any suggestions or comments, leave them in the comment section down below. The link to the app is in the description of the video as well as our email should you wish to contact us for business inquiries. Have a nice day.